Two houses, same street, same price, same storm, only one of them is still standing. This isn't luck. This isn't coincidence. This was engineered, decades before the storm ever arrived. I've been driving through Florida for 2 weeks trying to understand why this state builds differently from the rest of America. And what I found goes much deeper than hurricanes. If you've ever driven through a Florida neighborhood, something feels different. The houses are lower, the roof lines are flatter. There's a weight to them, a permanence, that you don't feel in Atlanta or Boston or Denver. Compare that to New England, or the Midwest, or the Pacific Northwest. Two-story wood frames, steep roofs, white clapboard. It's a completely different building language, same country, completely different houses. About 90% of American homes are built with wood frames, but in Florida, the numbers flip. Concrete block construction, what builders call CBS, is standard. Understanding why tells you something fundamental about how climate shapes the homes we live in. CBS stands for concrete block structure. The walls of a Florida home aren't built with lumber, they're built with hollow concrete blocks, filled with rebar and poured concrete. It's essentially a small fortress. In the rest of America, the walls of your house are built from wood. 2x4 or 2x6 lumber, spaced 16 inches apart. Strong enough for most conditions, but not for Florida's. The story starts just after World War II. Florida was growing fast. Soldiers came back, families moved south, and developers were building as fast as they could. Florida's climate was unlike anything the American building industry had experience with. The wood frame houses they were building up north were failing in Florida, not from hurricanes, from rot, from termites, from a humidity that never let up. They needed a different material. Concrete block had been used in commercial construction for decades. But in Florida, builders started applying it to residential homes. It worked, it didn't rot, it didn't warp, and termites couldn't eat it. Florida sits almost entirely in climate zones 1 and 2, the hottest, most humid zones in the continental United States. The design rules that work in Zone 5 simply don't apply here. Florida's humidity doesn't just make the air feel heavy, it changes the direction that moisture moves through your walls. And that single fact changes everything about what materials you can use. In a cold climate, moisture inside a warm house pushes outward through the walls. In Florida, the opposite happens. The hot, humid exterior air pushes inward. A wood frame wall designed for northern climates traps moisture inside, and it never dries out. Moisture trapped in a wood frame wall, in Florida's heat, becomes mold within weeks. It destroys insulation, rots structural lumber, creates air quality problems that don't show up until someone tears open the drywall. Concrete block doesn't have this problem, but the real villain of this story isn't moisture, it's something smaller, much smaller, and it arrived in Florida the same way many invasive species do, by accident in the middle of a war. The Formosan subterranean termite, native to East Asia. Accidentally imported to the United States through military shipping during World War II. By the 70s, it was established in Florida, and it was unlike any termite American builders had encountered before. A native subterranean termite colony might have 200,000 workers. A Formosan colony can have 10 million. A mature colony can consume a pound of wood every single day. They can hollow out the structural lumber of a wood frame house in 2 to 5 years. From the outside, the house looks completely normal. The damage is invisible. Until the floor gives way, or a wall buckles. Florida has the highest termite infestation rate in the continental United States. Not because of bad building, because of an invasive species that arrived before anyone understood what it could do. Concrete is immune. Termites cannot digest it. If you're still with me, you already know more about Florida construction than most people who move here ever find out. Every week we go deeper into stories like this. Subscribe so you're there for the next one. I want to show you exactly how a CBS house goes up, because it's genuinely fascinating and completely different from how wood frame works. The blocks are hollow, stacked in an alternating pattern to distribute load. Once the wall reaches height, vertical steel rebar is placed inside the hollow cores. Then grout, a fluid concrete mix, is poured into those cores, locking the rebar in place, creating a solid reinforced concrete column inside each row of blocks. The wall isn't just stacked blocks, it's a continuous reinforced concrete structure. Then stucco, a cement-based finish, seals the surface and gives Florida homes their characteristic smooth look. From the outside, you'd never know there was a fortress underneath. Let's talk about what happens when the wind arrives. Because Florida's hurricane risk is the most dramatic, and most scientifically understood, reason for its building choices. Florida has been struck by more hurricanes than any other US state. Its geography makes it almost unavoidable. A long peninsula in the collision zone between Gulf and Atlantic weather systems. A Category 1 hurricane brings winds of 75 miles per hour. Category 5, over 157. At those speeds, wind isn't a force that pushes on your house. It's a force that tears it apart from multiple directions simultaneously. Most people don't know this. It's not the positive pressure, the wind pushing on the walls, that causes most failures. It's the negative pressure, the suction on the leeward side. The wind literally pulls your roof off from the inside. The forces trying to lift a roof off a house in a Category 4 hurricane can exceed 4,000 pounds per linear foot of wall connection. The connection between your roof and your walls is the single most critical structural detail. Florida requires hurricane straps, galvanized steel clips that connect every roof truss to the concrete block wall below. In a major storm, this single metal clip is what keeps your roof attached to your house. After every major hurricane, forensic engineers study the damage patterns, and the finding is remarkably consistent. CBS structures with properly installed hurricane straps almost never lose their roofs. Wood frame structures fail at much higher rates. August 24, 1992. Hurricane Andrew, the most destructive hurricane in American history at that point. 175-mile-per-hour winds, South Florida. It became the defining test of Florida's building materials. 25,000 homes destroyed, another 100,000 severely damaged. But the pattern in the debris told a story. The CBS homes had a dramatically higher survival rate. Engineers documented everything. After Andrew, insurance companies began pricing differently. They'd always known concrete was stronger than wood. Now they had proof in the form of claim payments. The premium difference for CBS versus wood frame went from marginal to significant almost overnight. Some insurance companies stopped writing new policies for wood frame in coastal Florida counties entirely. Others priced it so high it became effectively unaffordable. The market had spoken, in the language of engineering data. Drive through any Florida real estate listing today and you'll see CBS construction listed as a feature. It became a selling point because it affects your insurance rate, your resale value, and your survivability in a storm. The most significant change came from the state itself. After Andrew, Florida rewrote its building code from the ground up. Updated after every major storm since, it's now widely considered the most stringent residential building code in the United States. Florida's code requires wind-rated windows and doors, specific roof-to-wall connections, specific anchor bolt spacing, requirements that don't exist in the standard national code used by most other states. And here's what's interesting. The code doesn't mandate concrete block. You can build wood frame in Florida, but the requirements are so stringent that by the time you've built a wind-rated wood frame house here, the cost difference from CBS has largely disappeared. Let's come back to termites, because the economic argument around them is one of the most under-discussed factors in Florida construction, and the one that most directly affects your wallet. Florida homeowners with wood frame construction typically pay for annual termite bonds, $300 to $500 per year. Over 30 years, $9,000 to $15,000. For concrete block, $0. Termites don't eat concrete. During a home purchase in Florida, a wood frame house requires a termite inspection. CBS doesn't, because there's nothing to inspect. This changes your contingencies, your negotiating position, and your ongoing ownership costs. One of the things I love about being inside a well-built CBS house is this. Look at the window reveals, the depth of the wall where the window sits. In wood frame, your wall is about 5.5 inches thick. In CBS, you're often looking at 8 to 10 inches. You can feel the mass. That mass matters for more than strength. Concrete has high thermal mass. It absorbs heat slowly during the day and releases it slowly at night. In Florida's climate, where air conditioning runs constantly, a CBS house can have meaningfully lower cooling costs. Studies by Florida Solar Energy Center found CBS homes can use 15 to 20% less energy for cooling than equivalent wood frame homes. Over the lifetime of a home, that's a significant number. Now let's talk about why the rest of America never made the switch. Because the answer involves economics, geography, and one of the most powerful supply chains in American construction history. The American wood frame construction industry is massive. The lumber supply chain employs hundreds of thousands of people and generates billions of dollars annually. It's deeply embedded in the American economy. In a typical non-coastal market, wood frame construction costs 5 to 15% less than CBS or masonry. For a $200,000 house, that's $10,000 to $30,000. That's real money. And builders compete on price. Speed matters too. An experienced framing crew can erect the structural shell of a wood frame house in 2 to 3 days. Concrete block construction takes significantly longer. In a housing market where speed equals profit, this matters. Geography plays a role. Concrete blocks are heavy and expensive to ship long distances. They're manufactured regionally, which in Florida is fine, with manufacturers throughout the state. But in Montana or Maine, sourcing block is a logistical challenge that wood doesn't present. And honestly, in most of America, wood frame works perfectly well. In the northern half of the country, the humidity and termite pressure that make wood problematic in Florida simply don't exist at the same level. Wood frame is the right material for most of America. The fascinating thing is the abruptness of the transition. Cross from Georgia into Florida, and within miles, the construction changes. Not because of a line on a map, but because of what's in the ground and in the air on each side of that line. Florida's geology matters too. The state sits on porous limestone, with a water table that in many areas is just a few feet below the surface. That's why Florida has almost no basements, and why foundation engineering here is completely different from northern states. Florida homes almost universally use slab-on-grade foundations, a thick concrete pad poured directly on the ground. The concrete block walls sit directly on this slab. The entire structural system, from foundation to roof connection, is designed around Florida's conditions. In Massachusetts, your foundation goes below the frost line, sometimes 4 feet deep. In Florida, the frost line doesn't exist. The foundation strategy is completely different, and the structural system built on top of it has to match. Interior design follows from construction. Tile floors are standard in Florida, ceramic or porcelain directly on the concrete slab. Carpet traps moisture in a humid climate. Tile is the right material for the environment. Florida's building history is older than people think. The 1920s saw the first Florida land boom, and that early construction was often frame or unreinforced masonry. Many of those buildings failed in the hurricanes of 1926 and 1928. The Great Miami Hurricane of 1926 struck a city that had been growing explosively for 5 years. The building failures were severe. The lessons, slowly, incompletely, began shifting Florida toward more resilient construction. It took decades and multiple disasters, and enormous pressure from insurance companies and engineering organizations. But the trajectory of Florida's building code is a story of progressive adaptation to a climate that never lets up. Other Gulf Coast states have faced the same reckoning. After Hurricane Katrina in 2005, Louisiana saw exactly what Florida saw after Andrew. CBS and masonry survived, wood frame failed, but Louisiana's code response was slower and less comprehensive than Florida's. Texas is an interesting case. The Gulf Coast, Houston, Galveston, Corpus Christi, has increasingly adopted masonry construction in response to hurricane risk. Inland Texas, away from the coast, remains overwhelmingly wood frame. Climate risk defines the material. Hawaii is the closest parallel to Florida. High humidity, hurricane risk, termite pressure, similar climate profile. And Hawaii, like Florida, is predominantly masonry and concrete for residential buildings. Climate creates building culture. The insurance numbers in Florida today are striking. A wood frame house in a coastal Florida county might pay twice the homeowner's insurance premium of an identical CBS house 2 blocks away. The difference is actuarial. Decades of claims data. Some coastal Florida counties have seen insurance companies exit the market entirely, refusing to write new policies for wood frame in high wind zones. This isn't discrimination, it's math. The claims history makes it economically uninsurable at a price homeowners will pay. For a homeowner buying in Florida today, the material of the house's construction should be one of the first questions. Not because of aesthetics, because of what it will cost you every year for as long as you own the property. I spent a day on a Florida construction site watching a CBS house go up. I've been in countless wood frame projects. The difference in the sound, the feel, the pace is remarkable. The pace of CBS construction is methodical. Each block is set with mortar, tapped level, checked for plumb. It's slower than framing. But what goes up doesn't come down. Once the blocks reach window height, horizontal rebar is laid in bond beam courses, grouted channels running continuously around the perimeter. Combined with vertical rebar in the filled cores, you have steel reinforcement in every direction. The windows in a Florida CBS home aren't standard windows. They're impact-resistant, laminated glass with a plastic interlayer that holds together if it shatters. In a hurricane, a broken window creates a pressure differential that can blow your roof off. Florida code in coastal zones requires either impact windows or storm shutters for every opening. This is another example of where Florida's code has evolved beyond the national standard, in direct response to documented disaster. The accordion shutters you see folded beside almost every Florida window aren't decoration. They're part of the engineered system, ready to protect every opening in the 30 minutes before a storm hits. This next part is the one I didn't see coming, and it changes how I think about everything I'd learned. If you want more investigations like this, subscribe. It takes 2 seconds. Here's where it gets interesting. Because concrete block construction, as good as it is, isn't the final word on building in Florida. There's a newer system that some engineers say is better, and it's neither wood nor traditional concrete block. ICF stands for Insulated Concrete Forms. You build the formwork for your concrete walls out of expanded polystyrene foam, the same material as a coffee cup. Pour concrete into the forms. The foam stays permanently, becoming the insulation. The result is a wall with the structural strength of reinforced concrete and the insulation value of 8 inches of foam. ICF walls typically achieve R values of 25 or higher, far beyond standard CBS construction. ICF homes in Florida have shown energy savings of 30 to 50% compared to wood frame, and 15 to 25% compared to standard CBS. The upfront cost is higher, but the operating cost is significantly lower. Contrary to what you might expect, ICF construction isn't dramatically slower than CBS. The foam blocks are lightweight and interlock quickly. A crew experienced with ICF assembles forms almost as fast as framing. Sound transmission is one of the most immediate differences owners notice. A thick concrete wall, whether CBS or ICF, attenuates exterior noise dramatically. Living in a concrete house in Florida, with traffic and storms and neighbors, is a qualitatively different acoustic experience. The 30-year cost analysis is where the material choice reveals itself. Wood frame, lowest upfront, highest ongoing. CBS, moderate both. ICF, highest upfront, lowest over the long term. The cheapest house to buy is the most expensive to own. Florida's existing housing stock is a fascinating archive of building technology evolution. Each decade's construction is identifiable by its details, every code revision visible in the buildings it produced. A 1950s CBS house has unreinforced block walls and a minimal roof connection. A 2020 CBS house has fully grouted reinforced walls, impact windows, and hurricane straps on every truss. Same basic material, completely different engineering, and the engineering keeps evolving. Because climate data suggests that the storms Florida will face in the coming decades will be stronger than the storms that shaped the building codes of the 1990s. Sea level rise adds another layer. Parts of South Florida that are currently above flood zones may not be in 20 years. Building codes are starting to address elevation requirements and flood-resistant construction, not just wind. It's a moving target. What I find remarkable is that Florida has conducted a century-long experiment in resilient construction, forced by climate and disaster into a building culture that the rest of the country hasn't needed to develop yet. Drive through a South Florida neighborhood and you're walking through the history of the state's progressive code changes. Each decade's construction is identifiable by its details, its window types, its roof geometry. I drove through Coral Gables, one of the oldest planned communities in South Florida. The houses from the 1920s are mostly masonry. Some of them survived Andrew. Some of them will probably outlast buildings constructed today. There's a growing movement toward factory-built modular homes in Florida using concrete panel systems, built in controlled factory conditions, to exact tolerances, quality consistency higher than anything achievable on a typical construction site. Three-dimensional concrete printing is already being used for experimental residential construction in Florida. A machine extrudes concrete layer by layer, building walls without forms or block laying. The structural performance is comparable to CBS. The labor cost is a fraction. The fundamental question, what material should Florida build with, may soon be answered not by choosing between wood and concrete, but by moving beyond both. The climate requires it. The technology is beginning to allow it. But here's the part of the story that Florida builders don't advertise. Concrete block construction has its own moisture problem, and it's not minor. Concrete is porous. In Florida's intense rain events, where several inches can fall in an hour, water can penetrate directly through unsealed concrete block walls, not through cracks, through the block itself. The stucco finish on a CBS exterior is the primary moisture barrier. When stucco cracks, from thermal movement, impact, poor installation, water finds its way into the wall cavity. Unlike a wood frame wall, concrete block walls don't have a designed drainage path for that water. The result can be as bad as anything wood frame produces. Mold colonies behind drywall, efflorescence on interior block surfaces, spalling concrete where rebar inside has corroded. It's less common than wood rot, but it happens. The solution is in the detailing. A properly built CBS house has multiple waterproofing layers, a cementitious coating on the block, a moisture barrier behind the stucco, careful flashing at all openings. Done right, CBS is essentially waterproof. Done cheaply, it leaks. This is the thing about building materials. The material itself is almost never the problem. The problem is almost always the quality of installation and design details. CBS can fail if poorly built. Wood frame can succeed if perfectly built. Material is necessary but not sufficient. I sat down with a structural engineer who spent 30 years building in Florida. I asked her, if you could build anywhere in Florida for your own family, what would you use? Her answer changed how I think about this entire question. She said, neither wood frame nor CBS is the best answer anymore. Both of them are compromises. The best material system for Florida today is something most residential buyers have never heard of, and the reason they haven't heard of it is economic, not technical. She was describing ICF, but not just for the walls. An integrated system, ICF walls, concrete roof deck instead of wood truss, impact windows, elevated slab, whole house moisture management. The price point, about 30% above standard CBS. 30% above CBS in Florida puts you in a price range where many buyers simply don't go. The houses that get built are the houses that appraise, and the market appraises what buyers are willing to pay for. So the best engineering solution sits unused, not because it doesn't work, but because the market hasn't priced it correctly. It's the same tension you find everywhere in construction. The best technical solution and the most economically accessible solution are rarely the same thing. The gap between what we know how to build and what we actually build is enormous. For a homeowner buying a wood frame house in Florida, add the insurance premium difference, add the termite bond, add the higher energy bills, add the potential storm repair deductible. The math changes significantly from the purchase price. I keep coming back to that Coral Gables neighborhood. A 100-year-old building built before modern codes existed, still standing. Not because old methods were better, but because the material was inherently durable and the details were done with care. Climate science suggests that as the Gulf of Mexico warms, hurricane intensification will happen faster and storm tracks will shift. Areas that have historically been low risk may face higher risk. The building code's geographic assumptions may need to expand. Some northern coastal states are already watching Florida's code evolution and beginning to borrow from it. Places that face hurricane risk but have historically built to lower standards. Florida's lesson is starting to travel north. The adaptation isn't just about wind. A concrete block house on a slab at current grade may be at flood risk in 20 years. Florida is beginning to require higher finished floor elevations in flood zones. Stem wall foundations that raise the first floor 2 to 4 feet. Elevation requirements add cost. But the alternative, flood insurance costs, flood damage, eventual displacement, costs far more. The upfront investment in resilience is almost always economically rational over a 30-year horizon. One of the reasons this knowledge gap persists is demographic. About 1,000 people move to Florida every day, many from northern states where wood frame is standard and concrete block is foreign. They bring their reference points with them. For buyers from Ohio or Michigan, CBS construction feels unfamiliar. The walls sound different when you knock on them. The renovation approach is different. You can't just move walls by cutting studs. The learning curve is real. Renovating a CBS house requires different tools. Cutting a window opening in a wood frame wall takes a saw and an hour. In a concrete block wall, it requires masonry cutting equipment and careful structural assessment. Doable, but not the same. Florida's aesthetics are a direct product of its structural requirements. The horizontal, low-slung houses, the deep window reveals, the hip roofs. Florida's architecture evolved to match its engineering. Material and form developed together. The best new houses in Florida use concrete construction as an expressive choice, letting the mass and solidity of concrete become part of the aesthetic rather than hiding it behind vinyl siding. Compare that to the wood frame subdivision home, which looks virtually identical in Florida as it does in Ohio. Vinyl siding, dimensional shingles, the same proportions. The climate has had no influence on the form, and the building code has to compensate for what the design isn't doing. The researchers I spoke with are optimistic. They believe the next generation of residential construction will move away from traditional material categories toward composite systems, prefabrication, designs that are climate-specific from the first sketch. There's a new generation of engineered wood products changing the calculus, cross-laminated timber, mass timber systems treated for moisture and termite resistance in ways that standard dimensional lumber can't be. They're entering the Florida market. Steel frame residential construction also has a growing presence in Florida. Steel doesn't rot, steel doesn't burn, termites can't eat it. In a Category 5 hurricane, a properly engineered steel frame structure performs exceptionally well. The honest answer to what's the best material for Florida is, it depends on your budget, your location, your risk tolerance, and your time horizon. There isn't one right answer. There are better and worse choices given your specific situation. I talked to a developer who builds exclusively in Florida. I asked what he tells buyers who want wood frame because it's what they're used to from back home. He said, I explain the cost of ownership. If they still want wood frame, I refer them to someone else. I won't build it here. The liability scares me. The neighborhoods rebuilt after Andrew look fundamentally different from the ones destroyed by it. Wider streets, higher elevations, newer materials, better engineering. Disaster didn't just destroy, it reset. And the reset was an improvement. Florida's insurance market is in crisis right now. Multiple major insurers have exited the state entirely. The remaining carriers are raising premiums dramatically. And the construction type of your home is one of the primary variables determining whether you can get coverage at all. This isn't abstract risk. Homeowners in Florida are receiving non-renewal notices, insurers walking away from wood frame in coastal zones. CBS homeowners in the same neighborhood are keeping their coverage. The material their home is built from is determining their insurability. The state is responding. Legislation is being considered that would further restrict wood frame construction in the highest risk coastal zones. What happened voluntarily after Andrew threw insurance pricing may soon be required by law. At the national level, the building codes that govern most of America are beginning to incorporate lessons from Florida. Wind speed maps are being updated. Moisture management requirements are expanding. The influence of Florida's hard-won experience is spreading. The family I talked to who rode out Hurricane Irma in their CBS home described the experience as surreal. The wind was incredible, but the house barely moved. The walls didn't flex. The noise was from outside, not from inside. They watched the storm. They didn't run from it. Compare that to the wood frame homeowners I spoke with who evacuated, not because they wanted to, but because their contractor told them the house wasn't rated for the storm. The material you build with determines whether your home is a shelter or a liability in an emergency. So what do you actually do with all of this? If you're buying in Florida, already own there, or thinking about it, here's what I'd want to know. First, know what the house is built from. CBS, wood frame, ICF. It matters enormously. This information is in the property record and should be on the MLS listing. Look before you fall in love. Second, get insurance quotes before you make an offer. The difference in annual premium between wood frame and CBS in a coastal Florida county can be $3,000 to $5,000 per year. Over 30 years, that's $90,000 to $150,000. Third, add the termite factor. Wood frame in Florida. Budget $300 to $500 annually for termite bond. CBS, zero. Cross that line item off your list entirely. Fourth, look at the roof geometry. Hip roofs, which slope on all four sides, perform significantly better in hurricanes than gabled roofs with vertical end walls that catch wind. In Florida, a hip roof is an engineering choice, not an aesthetic one. Fifth, ask about the roof-to-wall connection. Homes built after 2002 almost certainly have hurricane straps. Homes built before Andrew in 1992 need a structural engineer's evaluation of the connection. Sixth, windows and doors. Impact-rated openings are required by code in high wind zones. Older houses may have standard windows. Factor in the cost of replacement, or at minimum storm shutters for every opening. Every one of these elements qualifies for a premium discount through what's called a wind mitigation inspection. A $400 inspection can save you $1,000 a year, every year. It's one of the best investments in Florida home ownership. The wind mitigation inspector examines your roof covering, deck attachment, roof shape, roof-to-wall connection, and opening protection. The report goes directly to your insurer. Get one done, even on a house you already own. If you already own a wood frame house in Florida, you're not without options. Retrofitting hurricane straps, upgrading to impact windows, adding storm shutters, each upgrade reduces your risk and your insurance premium. The building is improvable. If you're building new, I'd encourage you to build slightly above the minimum code. The minimum is designed to protect life, not property. Better connections, better windows, better waterproofing. The payoff is asymmetric in a state where major storms are not if, but when. The builders I respect most in Florida build to their own standard, not just the code minimum. Because the code minimum is the floor, not the ceiling. And in this climate, the ceiling matters. I think about what Florida will look like in 50 years. Sea levels higher, storms more intense. The code will have evolved again. The houses standing in 50 years will be the ones built best today, not the ones built cheapest. Here's a reframe worth considering. We think about building materials as costs, but a well-chosen, well-built Florida home is actually an asset allocation decision. You're deciding how much risk you're willing to carry and how much you want to transfer to your building. California faces wildfire, the Midwest faces tornado, the Gulf Coast faces hurricane. The Pacific Northwest faces earthquake. Every region of America has a climate challenge its building stock wasn't fully designed for. Florida just learned its lesson first. There's a slow but real movement toward higher building standards nationally. Some states are adopting stronger wind provisions. Some are adding wildfire-resistant requirements. Florida's hard-won experience is influencing policy far beyond its borders. I keep coming back to those two houses, same street, same price. Different material. One is an evacuation decision, one is a shelter, and the difference between them, the 10 or 15% construction cost premium for concrete, is the smallest line item on a 30-year ownership spreadsheet. Florida didn't choose concrete because it's fashionable, it chose it because termites ate the wood, humidity rotted the wood, and hurricanes blew away the wood. The climate demanded a better material. And over 70 years, a better material won. The question isn't really, why does Florida build with concrete? The question is, why doesn't the rest of the country build more like Florida? Not because everyone faces hurricane risk, but because the culture of building thoughtfully for climate transfers everywhere. The buildings we construct in the next 20 years will face climate conditions that existing codes weren't fully designed for. The gap between what we know and what we require is closing, slowly. In the meantime, individual homeowners have to make their own decisions. Florida builds with concrete because its climate demanded it. And slowly, reluctantly, but inevitably, the rest of America is beginning to ask the same question Florida had to answer 70 years ago. What does our climate demand of our buildings? Your home is built with decisions that were made long before you arrived. Decisions about climate, economics, culture, and risk. Understanding those decisions is the first step to making better ones. Next week, I'm going inside something that's been hiding inside American walls for decades. A material that every contractor knows about and almost nobody talks about openly. If you want to be there, subscribe. I'll see you on the next one. The most durable homes aren't built from the cheapest material. They're built from the right material for the right place, done with the right details. Florida figured that out the hard way. Florida builds with concrete because the climate demanded it. The rest of America is beginning to ask, what is our climate demanding of us?